The system of linear equations has a unique solution. Find the solution using Gaussian elimination or Gauss-Jordan elimination. Well, my last video I did Gauss-Jordan elimination, so this one I'm going to do Gaussian elimination. So first what I need to do is turn this into a matrix. Once again, it's just the coefficients. So 1, 2, negative 1, 9. 1, 2, negative 1, 9. 2, 0, negative 1, negative 2. 3, 5, 2, 22. All right, so the whole goal in Gaussian elimination is to get zeros here and then a diagonal here, and then everything else we can just backward substitute. So all I need to do is get these three guys to be zeros. So I'm going to make this guy 0 first. So, and to tell you the truth, since I did another video slowly, I'm going to do two things at the same time on each one of these, not just one of these steps. So what I'm going to do is I need to, in order to get a 0 here, I'm going to multiply this by 3 and subtract it to row 3. So I'm going to take 3 times row 1 and subtract it to row 3, and then I'm going to replace row 3 with that. Also, at the same time, I'm going to create a 0 here by multiplying this by 2 and subtracting it to this row. So I'm going to take row 2 to row 1 and subtract it to row 2 and replace row 2 with that. So if I do those two things, so we get row 1 doesn't change, 2, negative 1, 9. The next row will change, and I'm going to be using this right here. So I'm going to double row 1 and subtract it to row 2. So I have double row 1, so that's 2, minus 2 is 0. And then I get double this, so that's 4, minus 0 is 4. Now if you notice, it used to be a 0 and it's not a 0 anymore. Don't get hung up on that. Don't try and use this 0. It just will get you confused. So what I'm going to do is get these two guys to be 0 and then not worry about this one at all. And then I'm going to do double this, which is going to be negative 2, and subtract it with negative 1. So that's negative 2 plus 1, which is negative 1. And then I'm going to double 9, which gives me 18. And then I'm going to subtract a negative 2, which ends up giving me 18 minus a negative 2, which is 18 plus 2, which is 20. Okay, 3 times this, subtract this. So 3 minus 3 is 0. And then we have 3 times 2, which is 6, minus 5, which is 1. And then 3 times negative 1, which is negative 3, minus 2 is negative 5. 3 times 9, which is 27, subtract 22 is going to be 5. Now I have the two zeros right where I needed them. So now I got to do is make this a 0. So what I'm going to do is I am going to take this row and subtract 4 times this row. So I'm going to take row 2 and subtract 4 times row 3 and replace that with row 3. So I end up getting, let's see, 0, subtract 4 times 0, which is 0. So that stays 0. Let's rewrite these. 1, 2, negative 1, 9. 0, 4, negative 1, 20. And then 0. Let's see. Row 2, subtract 4 times this. So 4 subtract 4 is going to be 0. And then I end up getting this, subtract 4 times this. Well, negative 4 times negative 5 is 20, so it's negative 1 plus 20, which is 19. And then I have this row subtract 4 times 5, which is 20, so 20 minus 20 is 0. And now I have a triangular matrix, so if I turn it back into a system of equations, so this isn't x, y, z, it's x1, x2, x3, just make sure you do that. So I have x1 plus 2x2s minus x3 equals 9. I have 4x squared minus x cubed equals 20. And then I have 19x cubed equals 0. Now, what I can do is divide both sides by 19. So if I divide both sides by 19, you get x3 equals 0. And then I can plug this 0 back into here, which then gives me 4x squared, not x squared, 4x2 minus 0 equals 20. So 4x2 equals 20. Divide by 4, you get x2 equals 5. Then what I can do is replace this here and this here, which then gives me x1 plus 2 times x2, so 2 times 5 is 10, minus 0 equals 9. Subtract 10 to both sides, and you get x1 equals negative 1. So you end up getting negative 1, 5, 0 as your answer.